Hello, my name is Bob Schleicher. I'm Vice President of Product Development for Dicon LED, and I'm very happy to be here today to talk about the use of Dicon's dense matrix LED technology in Kessil grow lights. This slide shows the traditional approach to packaging LED chips. The normal practice is high brightness LED chips, which tend to have a surface area of about 1 millimeter on a side, are individually placed in chip carriers, typically inside a small reflective cavity or reflective cup. And then following that, the bare device is sealed with a lens, typically made with plastic for cost reasons. In contrast, Dicon's dense matrix LED technology takes a totally different approach. It's not just an evolutionary next step in the process of making LEDs. It's truly a revolutionary, completely different breed of packaging technology. What we do is we take multiple LED chips and package them under one large glass lens. In the picture shown here, this particular version of one of our dense matrix LED arrays has 21 high brightness chips, all packed tightly together in an area that's about the size of a dime. So it's a lot of light energy coming out of a small space. These LED chips are secured through a special metal bonding process, and in turn are mounted on a patented multi-layer metal carrier board that serves to dissipate heat very quickly and efficiently from the bottoms of the LED chips. LEDs don't radiate heat energy or infrared energy, but they do generate a lot of heat at the chip site. And so it's critical to have a good thermal management approach that takes that heat and dissipates it out of the bottom of the LED chips through the metal carrier and to an underlying heat sink. So you can see some of the advantages of this approach. With traditional LEDs, you've got individually packaged LEDs. To get sufficient total light output for grow light applications, you need a lot of chips. And those chips would typically be spaced fairly far apart, either on a panel of some kind or perhaps on a light bar. As a result, light energy is spread out over a large area, and the light output of each of those individual chips is located differently, and it's beaming differently on the area surrounding the chip. So there's not very good uniformity of the content of the light from that sort of a product. With our approach, all of the light is coming from a very small confined space. There's a single lens, and we can have a very specially designed or tailored single reflector element to serve to focus the combined light output of all of those chips into a confined area. So we get a very high intensity of light with good control of the area of the light and the uniformity of the intensity of the light within that area. For plant growing applications, the traditional LED approach is also not very effective. It's really designed for general illumination purposes where you want to have light spread out over large areas. But for growing plants, it's just not as effective. Even if you put reflective material of some kind to build artificial walls around a plant growing area, that will serve to partially direct some of the wide angle light back toward the plant, but with a tremendous loss of efficiency. Light is hitting the plants at fairly high angles. That tends to be not very good for penetration of the light into the surfaces of the plant and the foliage. It's also true that if different wavelengths are being used for a variety of reasons, say several wavelengths of red or blue LEDs, the mix of light will not be uniform over the entire plant growing area. You'll get some wavelengths from this LED location, other wavelengths from that LED location, and the result is that different plants will see a different quality of light. With Dicon's approach, however, the dense matrix LED produces light from that very small confined area. The light from multiple LED chips and multiple wavelengths is extremely well mixed through the combination of that single lens and the single reflector element. And also, by designing the reflector element appropriately, all of the light energy can be directed into a well-defined, confined area so that it's all getting to the plants that are being grown. The photons and the light energy is hitting the plants at a much more uniform set of narrow angles, much more like what happens with natural sunlight. And as a result, you get very good penetration of light energy into the plant surfaces. The densely packed LEDs potentially of different wavelengths also provide a very uniform and intense light that's just perfect for plant growing applications. I hope I've been able to provide a little bit of insight into the depth of technology that is part of every Kessil grow light. Through the use of Daikin LED's dense matrix LED technology, Kessil grow lights are truly leading a spectral revolution.